Hello everyone, myself Zeel Bhatt and welcome to my channel Zeel's Pharmacy Tutorial. And today we are going to study about Ramachandran Plot. I am making this video on the request of one of my viewers. Even if you think that I could help you out in any of the topic, please comment the topic in the comment box below. So first of all, what is Ramachandran Plot? It is a way to visualize dihedral angles psi against phi of amino acid residues in protein structure. In the simple words, it is a way by which we could identify secondary structure of proteins depending upon the rotation or degree of freedom of dihedral angles psi and phi. Secondary structure of protein could be alpha helix, beta sheet or loop structure. So now, let us study about characteristics of Ramachandran plot. First, it contains 4 quadrants. So the Ramachandran plot is divided into 4 quadrants. First quadrant, second quadrant, third quadrant and fourth quadrant. Then second, y-axis will be psi angle and x-axis will be phi angle. So in the Ramachandran plot, this is psi angle on y-axis and phi angle on x-axis. The angles range from plus 180 degree to minus 180 degree on both the axes. So what are psi and phi angles? In this structure, oxygen is more electronegative than carbon. Hence it pulls electron pair towards it, making carbon positive. As the result, the lone pair of nitrogen creates partial double bond. Thus, it makes this bond rigid. The bond between C alpha and N is called phi bond, which is free to rotate. Similarly, in the case of C alpha C, the bond is called psi bond, which is also free to rotate. So the torsional angles or dihedral angles formed between C alpha and N is called phi angle, and the torsional or the dihedral angle formed between C alpha and C is called psi angle. Now the rotation mainly depends upon this R. If this R is simple, for example as in glycine it is H, the rotation is more. Similarly, if R is of proline which has a complex structure and is bulkier group, the rotation is very difficult. Then third, the finite position in the plot will indicate the finite secondary structure of protein. This region in first quadrant indicates antiparallel beta sheets. Then this region in the first quadrant indicates parallel beta sheets. Similarly, in the second quadrant, this region indicates left-handed alpha helix, and in the third quadrant, this region indicates right-handed alpha helix. And the last fourth, the plot contains both allowed and disallowed region. In computing Ramachandran plot, atoms are treated as hard spheres where dimensions corresponds to their van der Waals radii. Any angle that results into the collision of the spheres are regarded as sterically unfavorable, and hence such conformation are not allowed. Based on this principle, the graph is divided into 3 regions. First is the most allowed region, then second is allowed region, and the third is disallowed region. Most allowed regions do not have any steric hindrance. Allowed region corresponds to the conformations that could be possible if slightly shorter van der Waals radii are used in calculation. Disallowed region corresponds to the conformation that are sterically unfavorable, and this is due to the presence of the bulkier group. Here, red color regions are most allowed region, then yellow color regions are allowed region, and white color regions are disallowed region. Thank you. Do not forget to like, share and subscribe. You could also follow us on Facebook and Instagram. To reach out our Facebook and Instagram pages, you could use hashtag Zeel's Pharmacy Tutorial or hashtag ZPT.